Welcome you all. First of all, thanks for being here on my YouTube channel. Please subscribe our channel for more number of electrical videos. Let's move on to the topic, that is RL series circuits. Here resistance and inductance are connected in series across AC supply, that is V is equal to Vm sin omega t. Due to voltage, current will flow through the resistance and inductance. I'll be giving one suggestion. Please watch my previous videos for better understanding for this derivation. Okay. So let's move on to the waveform for understanding. There is a voltage and then there is a current lags behind voltage at an angle phi. Okay, so this one is V is equal to Vm sin omega t, constant for all the concepts AC, and I is equal to Im sin omega t minus any guesses? Phi, exactly, the phase angle, phase difference. So if you have taken phi by 2, that is pure inductance or capacitance. So you will be getting zero answer after the derivation. It should be sin omega t minus phi. Right. So there is a clue. Power is equal to Vi cos phi. So finally we will derive this equation, this phi this way. So finally we will get this equation after derivation this way. So there is a vector diagram. So see, this one is current and then this one is voltage across resistance. So I and V are in phase with each other for resistance. And what about inductance? Current leads by voltage at an angle 90 degree, right? So this one is total voltage. This one is VL, right? So this one is phi. So see here, this is a vector diagram for your circuit diagram. See, I and V are in phase with each other, and then current lags by voltage at an angle 90 degree for inductance. So this is a total voltage. This is a waveform. So V is equal to Vm sin omega t, I is equal to Im sin omega t minus phi. There is a equations. I'll be drawing one vector diagram over here. This one is a VL, this one is a VR, and then this is total voltage. This one is phase angle. So VR is a voltage drop across resistance, VL is a voltage drop across inductance, and this is IR, and then this one is a voltage, total voltage, right? So current and voltage are in phase with each other for resistance. Current lags by voltage at an angle 90 degree for inductance. This is a RL circuit. So according to Pythagoras theorem, V square is equal to VR square plus VL square, right? So V is equal to what? Root of VR square plus VL square, right? See here, this equation. So what about VR? VR is equal to I into R. VL is equal to I into XL. See here, X into XL, I into R. So I'll just substitute over here this equation. So I into R square, I into XL square, R square plus XL square, I common outside. So finally we'll get V is equal to I into Z. So where Z is equal to root of R square plus XL square. Other formula, Z is equal to R plus JXL. That is impedance avoiding the flow of AC current. This is the imaginary part, magnetic field, and then this is the real part, resistance. Next there is a equation, Z is equal to R plus JXL, right? Where phi is equal to tan inverse of XL by R. So see here, XL by R over here, and then XL is equal to omega L by R. You can use this formula also, VL by VR. VL is equal to I into XL, VR is equal to I into R. Voltage drop across resistance, voltage drop across inductance. So already we discussed in the mathematics, A plus JB, complex value. So if you want to calculate in polar form, A square plus B square, tan inverse of B by A. Already we used in the mathematics. So next there is a instantaneous power. Power is equal to V. V is this one, I is this one, right? So I'll be using sin A sin B formula. Sin A sin B, that is 1 by 2 cos A minus B cos A plus B. Okay. So I'll be using over here, power is equal to Vm Im common outside. 1 by 2 cos omega t minus omega t minus phi whole, minus to minus plus. So this here minus will be there. Minus cos omega t plus omega t minus phi. So definitely omega t get cancelled. Only you will get Vm Im by 2 cos phi minus Vm. I just multiplied over here. Vm Im by 2 cos 2 omega t minus phi. This part is fluctuating part. This one is constant part. So this is periodically varying part. See here, frequency 2 times compared to supply frequency, right? So this is the equation. This is the periodically varying part. This is a constant part. This is instantaneous power. Next, there is a average power. How we will get average power? By integrating the instantaneous power. This part is instantaneous area under one cycle. See, 0 to 2 pi will be there, 2 pi is the base. So with respect to d omega t, see here, with respect to d omega t, this part becomes 0 because after applying the limits, I mean 0 to 2 pi, definitely we'll get 0 answer. Only this constant part will be available. See here, Vm Im cos divided by 2. So after converting this one 2 into root 2 into root 2, so Vm by root 2, Im by root 2 cos phi, finally we get power is equal to Vi cos phi. Next, there is a power, voltage, current waveform. There is a small amount of power, just I am drawing here. So, this power transferred or power flow from source to the load. This power is large amount of power will be there, right? This one is power flow from source to the load. Similarly, this one and this one. Already we discussed in the L circuit, right? So, this is the power, voltage, current waveform, right? So, see here how we got this one. Voltage positive, current is negative. So, small amount of power. And then see here, large amount of voltage, large amount of current will get large amount of positive power. Again, negative current, positive voltage will get negative power, small amount of power. So here, power is equal to Vi cos phi because this area is not equal to this area. So that's why power is equal to Vi cos phi, not equal to 0. If it is equal, definitely we get 0 answer. Next, there is a RC series circuit. See here, resistance and then capacitance are connected in series across edges of layer, that is V is equal to Vm sin omega t. Due to voltage, current will flow through the resistance and capacitance. See here, there is a waveform. This is a voltage. This is a current. Current leads by voltage at an angle phi. Okay, this is phi or this angle phi. Current leads by voltage at an angle phi. This is voltage. V is equal to what? Vm sin omega t. I is equal to what? Im sin omega t. Any guesses? Definitely plus phi. Okay, for inductance minus pi. So the vector diagram is like this. I, R and then VR are in phase with each other for this part. Okay, and then here there is a VC, I mean voltage. Current leads by voltage at an angle 90 degree. So this is V, this is phi, this phi. Okay, this phi. So this is the vector diagram for this one. For resistance, current and voltage are in phase with each other. For capacitance, see current leads, voltage lags. This is the vector diagram. Okay. See here, current leads by voltage at an angle 90 degree for VC, and this is a phi. This is the total voltage. This is VR. So V is equal to Vm sin omega t. I is equal to Im sin omega t plus phi for capacitor. Okay. So this is the equation. Just I'll draw vector diagram. So this is vector diagram. This is VC and then this is VR and then this is total voltage, this is phi. So VC is equal to I into XC and then VR is equal to I into R, V is equal to I into Z. See here, V square is equal to what? VR square plus VL square. So if you want V only, VR square, root will be there, VL square. So just VR is equal to what? I into R, I into XC, I substitute over here, VR is equal to I into Z, Z is equal to root of R square plus XC square. So finally, phase angle if you want tan inverse of XC by R, right? XC is equal to what? 1 by 2 pi FC, right? So power is equal to what? Vi cos phi. If you want to calculate power loss, so just you substitute V is equal to what? I into Z into I. Cos phi is equal to what? Cos phi is equal to R by Z, right? See here from this one, cos phi. If you want phi, cos phi is equal to what? R and then divided by Z is equal to R by Z. So we will get I square R as the losses.